Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mosaic Works studios. And what I have for you today is a reaction, analysis, commentary to a LinkedIn post by Matthias Patzak, I hope, ex-CTO, author of All Hands on Tech. And he is talking about monoliths versus microservices. And I think this is an interesting topic. Now, before we move on, thank you so much for your understanding. I had to delay this video a little bit. Normally we publish videos on Saturdays. This one will come on Monday afternoon, and the reason is I had a full week teaching architecting microservices. I also tried to upgrade the computer that we use for recordings, and Ubuntu bugged out during the upgrade, and this created a bunch of problems, which meant that I had to work a little bit more, and I didn't really have time anymore because there were another thing happening, which is this book was just published, Debunking C++ Myths. I'm one of the co-authors along with Ferenc Deac, and this is a really fun book that we've been working on last year, and now it's come out and we have to do a little bit of marketing. So I was very late Friday night in a meetup with developers around the San Jose area, and it was really fun. I will post the video, and you can watch it if you want to. And you have any questions, let us know. Anyway, let's get on with it. I wanted to thank you for your understanding, but now let's move to our main part of the content. So Matthias Patzak, ex-CTO, author of All Hands of Tech, he's talking, it's a rather, let's say, 1 month old post. And I found it really interesting, particularly because last week and in the past few weeks, microservices have been on top of my mind. And I noticed how some things have evolved, but regarding the industry's understanding of microservices, but others haven't. So it's still not, let's say, closed topic. Many teams are still making mistakes that are avoidable. And I found this post quite interesting. So let's go a little bit through it. Modular, monolith versus microservices. One wins the sprint, the other wins the marathon. Here's how I think about it. In my humble opinion, these are the critical factors that should influence the architecture decision. Organization size and structure. Your teams will shape your architecture. Business context. Your growth plans matter more than technical preferences. Technical requirements. Scale, performance, and integration needs. Operational capabilities, your DevOps maturity is crucial. And I agree, by the way, these are criteria that influence every architectural decision. I've worked a lot with, let's say, beginner architects, people who are switching from programming to architecture. And while it seems like it's the same world, the world is completely different. So architecture is about strategic technical decisions. And by strategic, the simplest way of thinking about it is decisions that affect more people for a longer period of time. These are decisions that you need to make, or somebody needs to make. So they will be made anyway if you want to start a project. For example, what technologies you use, how the code is structured, what practices you are using, who's responsible for what, how the responsibilities are split between different components, and so on. And of course, you'd like this decision to be made by people who have the necessary mindset, the correct mindset to make them. It's important to understand that these decisions are necessarily made with incomplete information, because the only time you have complete information in architecture is after everything was developed and it runs, and you can measure it and you can figure out what's good and not. So when you start, you necessarily don't have complete information, which necessarily means that you'll make mistakes when making architectural decisions, and those mistakes will turn into, they can be quite costly, but it's the game. That's where we are. We cannot predict everything, and some of these decisions need to be refactored. You might need to restructure your architecture in order to fit what you understand now and you didn't understand previously, and that's fine. I mean, it's unavoidable. It's not, nobody wants to do that, but it's unavoidable. And another thing that you need to understand is that every architectural decision has trade-offs. It has advantages and disadvantages. There's never a perfect architectural decision. You can only get to the least worst architectural decision. And with this being said, the next step that is important is that your architecture is necessarily influenced by politics, by organization structure, by the business, and so on. Because what architecture is basically about taking care of something, taking care of a technical product for a business. This is the responsibility of an architect. And therefore, that product needs to serve the business. And the most important architectural decisions are the ones that are local to your context, to your business. You cannot copy those decisions. Those are the most important ones. And those are the ones that you necessarily have to make. You cannot copy them from anywhere else, right? And if nobody, so this decision will be made anyway. The question is, who will make them? Will it be people who are who have the necessary depth in terms of knowledge, the necessary vision, or will it be people who don't? That's the only question you can ask. All right. And so when he's talking here about organization size and structure, yeah, the way your teams are organized and how large the organization is and what budgets you have influences the architecture. There's a well-known law called Conway's law, which says that organizations are constrained to produce architectures that map the communication structure in the organization. So this means if you have one team, let's say you have a team of 7 people that is co-located, they can speak to each other very easily. Or even multiple teams, but they are all co-located and they are just one door away, or 2 meters walking away. Then they are more likely to have a more coupled architecture, because it's easier for them to discuss the potential changes and negotiate and so on, and they know each other and so on. But if you have one team in Australia, one team in Romania, one team in US, and one team in India, then those teams will tend to create more separate modules, because it's harder for them to converse, harder for them to negotiate, to discuss the different aspects of architecture. And definitely organization structure influences this, and organization size influences as well. If you have a large organization, well, there tends to be more bureaucracy, more people are involved, more politics. You need to convince more people who have different interests. maybe converging, but not always fully aligned. So yeah, it's that's the job. And then business context, your growth plans matter more than technical preferences. Of course, if you expect to grow like 10 users per week, it's completely different from expecting to grow 10 million users per week. That's the size of scale, of scalability matters. It's really important. I've seen this again and again. This, by the way, is another reason why it's not a good idea to copy from Google, Microsoft, and other huge companies, Facebook, because scale matters. It's likely you don't have the challenges that Google, Microsoft, Facebook face. You probably have other challenges, and your architecture needs to be set up for those challenges and not for the ones that are in other companies. Technical requirements, scale performance and integration needs. And please notice that what he's talking about is cross-functional or non-functional requirement. It's not about necessarily about what the product does, but it's more about how the product needs to behave in operation. How fast does it need to scale? How elastic does it need? The scaling needs to be. How resilient? Security, performance. These are the big questions you usually ask. And finally, operational capabilities. Your DevOps maturity is crucial. Absolutely. So you should be able today, with all the tools that we have, you should be able to destroy and rebuild your infrastructure within a reasonable time frame. Right? Now, what reasonable means, that depends on the business, but what's important is this, that you should be able to rebuild, respin, let's say, your infrastructure from all your existing scripts and infrastructure automation pretty fast. Okay, and now he looks at a comparison. On the short-term view, 1 to 2 years, modular monolith takes the lead. Faster initial development and deployment, lower upfront infrastructure costs, simpler debugging and testing processes, easier to refactor and adjust module boundaries, more familiar to most development teams, quicker to implement security patterns, lower operational complexity during initial launch. Absolutely. So modular monoliths are a great way to go. The only problem that we have with modular monoliths is the problem that microservices kind of force you into solving, which is finding modules. So if you can figure out what are good modules, then you already have a lot of the work done. And it almost doesn't matter. It does, but it almost doesn't matter if you use modular monolith or microservices. By the way, one thing you could try is start with the actor model. So have a monolith that uses the actor model, because the actor model kind of forces you into the same modular approach. You have to implement separate modules that discuss between each other, and it has a strong boundary between them because you cannot call directly another actor, but you have to send messages. And that's, to me, that's a good middle point. And then you can switch to, or easier switch to microservices. It's not as simple as a monolith would be. Like if you're doing Java, let's say you're doing a web application in Java, probably Spring Boot is something that you can use. It's easy to set up. Most Java developers are familiar with it, can start a project with it, and so on. But with actor model, it would be a little bit more different. It's a new paradigm, but it forces you into considering the strong boundaries which don't exist into a monolith. That's one of the big challenges, and I think one of the reasons we rely on microservices for so much of architecture is because we don't have modules with strong boundaries as first-class citizens in our languages. I know Java and C++ have started to kind of look into it. There's something in Python, but not as great. I mean, ideally, you'd like to have separate modules with a clear interface, cannot access their internals. They can be deployed, started, stopped. That would be the ideal way of dealing with this. And the actor model is pretty close to that. So yeah, there are good reasons for go with modular monoliths, but just be aware it needs to be modular. Otherwise, you end up with spaghetti code, as it usually happens. Why microservices need more effort initially? Higher initial infrastructure setup costs, more time spent on DevOps, setup and automation, steeper learning curve for teams, higher initial complexity in deployment pipelines, more time spent on service contracts and boundaries, greater initial investment in monitoring and observability. Yeah, so you have a lot more things to set up, basically. And if you have a strong operations team, you can probably do this without a lot of issues. But yeah, teams still need to learn how to run microservices. Ideally, you'd have a group that is able to do the domain analysis so that they can create the bounded contexts and the specifications for microservices, at least initially, while teams can start by developing and then eventually can contribute. But you need a lot of infrastructure. You need to have some kind of deployment, probably something based on Kubernetes. You need to have database engines available for various contexts. Maybe you start just with one. Maybe you start just with one database server on one computer, but with separate schemas, because each microservice should have its own separate database. Yeah, but there is a lot of infrastructure. You need to set up logging, monitoring, scaling, and auto scaling. You need to security, versioning, and so on. So lots and lots of stuff. And I am extremely surprised by how many teams started doing this without even reading the fundamental books on microservices. Just, take the book, read it. Building Microservices, second edition by Sam Newman. It's really good. It takes you through all these challenges and you can figure out advantages, disadvantages. You learn about the CAP theorem, or you can come to one of my training programs. On the long term, 2 to 5 years, though modular monoliths tend to fall into disrepair if they are not developed in a disciplined manner, may become harder to maintain as code-based growths, could face scaling challenges with increased load, technology update affect entire application, risk of module boundaries becoming blurred over time, yeah. Potential performance bottlenecks with single database, yeah. Harder to implement major architectural changes, yes. So he's right on all of these. It's really important to get these things right. Otherwise, yeah, maybe you can split the monolith into microservices at some point and, or start with the actor model. That's another option, I think. Here, microservices show their strength. If you have an organization that can handle it, easier to adopt new technologies selectively. Yeah, this is one of the great things. But the team needs to be mature because managing multiple technologies in microservices is not a no cost. It has some cost associated. Better support for team growth and autonomy, more flexible scaling options, easier to replace or upgrade individual services, better fault isolation, more options for optimization and cost management, higher potential for reuse across different products. Yeah, you also need, depending on your communication style that you pick for microservices, you might need circuit breakers in order to isolate faults. Anyway, you need to think about graceful degradation for your services. Yeah, micro front ends would be a great idea. So there are a bunch of things here. But a well-designed modular monolith can be gradually transformed into microservices as needed, as we discussed previously. Start with modular monolith, establish clear module boundaries, implement internal APIs between modules, extract modules into services as needed, maintain hybrid architecture during transition. This approach provides a pragmatic path that can evolve with your organization's needs and capabilities. What's your experience? Have you successfully managed a modular monolith at scale, which scale, or navigated the transition to microservices? Share your story below. All right. And so there's a lot of comments. I will post the link to this post in the description. And I think it's right. I mean, it's not complete, obviously. There are a lot more things you need to take into account, but this is a LinkedIn post, so you shouldn't expect a lot of details here, but I think it touches on the most important parts. For me, this ability to maintain discipline, boundaries between modules, this is key. This is really key. And I think this solves a lot of other problems. If we would have strong module boundaries in our programming language, imagine the power of this. You could split into various teams. Okay, you cannot start multiple instances of one and scale just one of the modules, but maybe you can. Okay, you can if it's the actor framework, actually, the actor model. But with normal modules, you won't be able to. But then you can spin it into a microservice fairly easily, or at least it should be fairly easily. You still need to figure out some, serialization, deserialization, take latency into account, figure out what type of communication you want. Do you want synchronous or event-based or asynchronous? How do you manage dependencies and all that? There's a lot more there. But honestly, if we had strong boundaries for modules in our programming languages, this would already be a first step that would solve so many problems. You could develop in parallel. You'd be forced to think in modules, which hopefully would mean that more people do domain modeling and go through domain-driven design to split into modules. And if you do that, then the changes are localized. You have tests, you will have contracts. It's all really helpful if we were able to do that. And then one interesting thing for web applications is that you have, well, at least for the graphical user interface, is that you have a natural module, which is, or natural separation, which is the URL. Based on the URLs, you can separate the modules. It's quite interesting and fascinating to do that. And think for a moment what would mean for your web application to have separate modules, each with their own database. because that would be the first step towards microservices. And between themselves, they only communicate through either events or through very specific APIs. Yeah. So I think we need, if there's one thing I would want from our technologies, is to get this support for strong modules with strong boundaries in the programming languages. I think this would also solve the issues with long lasting branches and a lot of other stuff. You could also deploy side by side different modules. You could test them in production. For example, you could have two modules, same interface, uh, one that is under test, the other one that is in production. And when the calls come, they go to both modules. The return value is taken from the stable version, but you can compare the responses from the new one and from the old one, and that's how you can test for a while. And that's all possible if you have these separate modules. It would be just really cool. Anyway, let me know what you think about all this. I hope you find this interesting. Let us know in the comments, because we love comments and we love getting in touch with you and knowing what your thoughts are, what your questions are, what, if you've done microservices, what challenges you had. If you tried modular monoliths, what challenges did you have? Or if it's your first time learning about either of those things, what else would you like to know? What are some curiosities? There are no silly questions. It's just about spreading some knowledge. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.